So this is the Chapter 12 note page, and there's a couple tools that they're giving you that you're going to need to help you solve these problems. First one is obviously the unit circle, and then if you flip over to page 22, you're also going to see that they give you the trig identities for proving the equations are always true. So on page 21, they want you to reference the unit circle to check and see where each of these solutions are on the unit circle. You can also graph these in Desmos. So you could go into Desmos, graph the sine of x, and graph negative rad 2 over 2, and you would see where their intersection is at. The easiest way is just to use the unit circle and to look for where the sine is at negative rad 2 over 2. So the first place it occurs is at 5 pi over 4, and the y value is the negative rad 2 over 2, so that's where that comes from. And so you write that answer down, then you write that you're going to need to write that it occurs every time you go around that unit circle. Okay? The second place it happens is at 7 pi over 4. That's where your sine is at negative rad 2 over 2. And just notate that it happens every time you go around the unit circle. In the next box, we have the tangent of 2x is equal to rad 3. And so the tangent is sine divided by cosine. So we would need where we have the sine divided by the cosine. So if we take the cosine divided by the sine and we invert this, the 2's are going to cancel and we're going to be left with rad 3, which happens at pi over 6. This one's going to happen every half of pi. So we're going to notate that that one is happening every half pi rotation. In the bottom box, you want to know where the cosine of 2x is equal to rad 3 over 2. That is also happening at pi over 6. But then we need to divide it by 2. So we're going to actually have it at pi over 12. And then we just need to notate where it's happening. Again, you can check it in Desmos and see where it's happening and then notate that it's going to happen every pi rotation. In the last box, we want to get rid of the 1/3, so we multiply both sides by 3, giving us 2 sine of x on the left and 1 on the right. Then we're going to divide by that 2, so we want to know where sine is equal to 1/2. It's happening in 2 spots. It's happening at pi over 6, and it's happening at 5 pi over 6. And then it's going to happen every 2 pi rotation. In your team of 4, you're going to work on the 2 problems together at the bottom of page 22. And then there's a worksheet for you to work on when you're done.